Hello students, in this video we are going to discuss Fourier transform. In this we are discussing Fourier sine and cosine transforms. Fourier sine transform is defined by fs of u. So you can see the difference. Previously you have studied Fourier transform. It was f of u. Here fs of u is nothing but sine transform. And integral 0 to infinity. In Fourier transform we have integral minus infinity to infinity. F of x, here f of x sin ux dx. So in a Fourier transform we have e power I ux. E power I ux can be written as both sin I cos ux and sin ux term. So if you want sine transform, we write sin ux dx. Similarly, we can define Fourier cosine transform. Here C we have, so that represent cosine. Fc of u is integral 0 to infinity f of x cos ux dx. And inverse Fourier transform is defined by, so here in a Fourier transform we are finding x to u. So that's why we have fs of u. So finally our answer is, here in a inverse Fourier transform u to x. So therefore it is f of x. The answer is f of x 2 by pi integral 0 to infinity. If you are finding sine inverse sine transform, you have to take Fourier sine transform and sin ux du. Sin ux du. And for inverse Fourier cosine transform is defined by, so 2 by pi integral 0 to infinity fc of u cos ux du. So now we'll solve the problem. The problem on sine and cosine transform we have here. We given the function is f of x equal to e power minus alpha x, where alpha greater than 0. We have to find sine and cosine Fourier transform. So first I'll take Fourier sine transform. So that is given by fs of u is integral 0 to infinity f of x sin ux dx. Now we substitute for the function integral 0 to infinity. Function is e power minus alpha x sin ux dx. Now we integrate this by the standard integration formula. We have that integral e power ax sin bx dx given by e power ax divided by a square plus b square in the bracket a sin bx minus b cos bx. Following this, we can integrate the above integral as integral e power minus alpha x by, where a in our formula minus alpha, b is u. So therefore we can write this as alpha square plus u square. A square plus b square become alpha square plus u square, and a is what? Minus alpha sin ux, b is u, so minus u cos bx. Apply the limit 0 to infinity. When you apply the limit, upper limit here, we get e power minus infinity, that is 0. So for applying upper limit, we get it 0. Applying lower limit, we get this as 1 over minus 1 over alpha square plus u square, because e power 0 is 1. And also sin 0 is 0, cos 0 is 1. Therefore, you are applying lower limit. I took minus already. In the bracket, we get only minus u. So finally, our sine transform answer will be u square divided by, it's u divided by alpha square plus u square. Now let us find the cosine transform of the given function. First I'll write the formula of Fourier cosine transform is given by integral 0 to infinity f of x cos ux dx. Since the function is e power minus alpha x, e cos ux dx. So formula for this is e power ax cos bx can be written as integration e power ax divided by a square plus b square a cos bx plus b sin bx. So following this, you can write the above integral as e power minus alpha x by where a is minus alpha, alpha square, b is u, u square, my a minus alpha cos ux plus b plus u sin ux. So apply the limit 0 to infinity. When you apply the upper limit, it becomes 0 because e power minus infinity is 0. And therefore we apply the lower limit. When you are applying lower limit, we should consider minus. Then e power 0 is 1 divided by alpha square plus u square, and in the bracket you have minus alpha cos 0 1 and sin 0 0. Cos 0 1 sin 0 0 e power 0 1. So we get 1 divided by alpha square plus u square bracket minus alpha into 1 u into 0 gives minus alpha. So it gives finally Fourier cosine transform is alpha divided by alpha square plus u square. The next problem is find the infinite Fourier sine transform of the function e power minus modulus of x and hence evaluate integral 0 to infinity x sine mx divided by 1 plus x square dx where m greater than 0. So first we write what is the Fourier sine transform formula. So that is Fourier fs of u is integral 0 to infinity f of x sin ux dx. Now substituting for the function, we get fs of u as integral 0 to infinity e power minus modulus of x sin ux dx. But e power minus modulus of x, we have the interval is positive range. 0 to infinity is a positive range. In a positive range, modulus of x is plus x. So therefore, the function e power minus modulus of x become e power minus modulus of x is plus x. So e power minus x sin ux dx. Now using the formula, you can write this as, in a previous problem you have seen the formula is what? E power minus x divided by a, where a is in our integral minus 1, b is u. So therefore it becomes 1 plus u square, in the denominator 1 plus u square, and minus a is minus 1 sin ux, and for sine term we have minus b, so u minus u cos ux. Then apply the limits 0 to infinity. So when you apply the upper limit, it is 0 because e power minus infinity is 0. Now we apply the lower limit, that's why I am taking minus 1. E power 0 is 1 divided by 1 plus u square. So this you are applying lower limit to x. So minus e power 0 is 1 divided by 1 plus u square, and in the bracket what we get, if you substitute x is 0, sin 0 0 minus u cos 0 1. Therefore we get minus u. So we get fs of u is u divided by 1 plus u square. Next we have to evaluate some result. For that we have to consider inverse Fourier sine transform. Because we obtain sine transform, we have to consider inverse Fourier sine transform. That is given by f of x is equal to 2 by pi integral 0 to infinity f s of u sin ux du. So we know that f of x is e power minus modulus of x. Now we substitute for the Fourier sine transform we obtained, that is what fs of u is u divided by 1 plus u square. So here we obtained Fourier sine transform, that we are substituting sine ux du and e power minus mod x. To get the required result, we should replace here u is x because we want x divided by 1 plus x square. So let us replace u is x. Then also parallelly we have to replace x to m. So in the same step you have to replace u to x and x to m. So therefore where you have x, that become m, where you have u, that become x. So therefore we get it is 2 by pi integral 0 to infinity x divided by 1 plus x square sine mx du can be written as dx and e power minus mod m, substituting x is m. Then m greater than 0, therefore you can write this as, this can be written as e power minus m because m is greater than 0. Then what is required? So what they are asking, what is integral 0 to infinity x divided by 1 plus x square sine mx dx. This is what, if you take cross multiplication here, so this become the result as pi by 2 e power minus m. So this is our required result finally. The next problem we have here, the function is splits over the different interval. Overall we have 0 to 2. Okay, they are asking to find the cosine transform. So first I'll write the formula of cosine transform. Fsc of u is integral 0 to infinity f of x cos ux dx. Now we substitute for the function how they split in the given function. So fc of u, so I'll first take 0 to 1. There the function is x cos ux. And next dx. Next I'll take 1 to 2. There the function is 2 minus x and I'll write cos ux dx. For the remaining 2 to infinity plus 2 to infinity, the function is 0. So cos ux dx. So therefore what happens, in this gets cancelled. So this is 0 because we have the integrand 0. Remaining, let us start integration by taking x is u, cos ux is v. In the next integral, 2 minus x is u, cos ux is v. So we start integration keeping first function x as it is, integration of cos ux sin ux with respect to x, so therefore divide by u. Next, minus differentiation of x is 1 and integration of sin ux will be minus cos ux divided by u square. So this completes, so apply the limit 0 to 1. Next we have a plus 2 minus x, integration of sin cos ux is sin ux by u, minus differentiation of 2 minus x will be minus 1, therefore this will become plus 1, and integration of sin ux is minus cos ux divided by u square. So this minus gets cancelled before applying the limit, and here I am applying the limit 0 to 2. Now let's apply the limits one by one. So if you substitute upper limit x is 1 in the entire equation, we get sin u by u, substituting x is 1, plus cos u divided by u square. Substituting lower limit x is 0, this becomes 0, and this becomes cos 0 is 1 divided by u square, and since it is a lower limit, we get minus 1 by u square. So first part is completed. Next I'll apply the upper limit x is 2 to this term. X is 2, so 2 minus 2, this becomes 0. Next we apply here x is 2, we get minus cos 2u by u square. Now we apply the lower limit, x is 1 to this term, so 2 minus 1, 1, so 1, and I am applying lower limit, I take minus 1 sin u divided by u. Next I am applying lower limit to the second term, there are already minus, so therefore we take plus cos u by u square. Now what we get, so we have sin u by u minus sin u by u gets cancelled, and you can write this as overall 1 by u square is common. 1 by u square is common, and I can write this as cos u, and making these two combination we can write minus of 1 plus cos 2u. 1 plus cos 2u. So then 2 cos u, we have overall 2 cos 2u. So then I can simplify that. This is what 1 plus cos 2u is cos square 2 cos square u. Then if you take 2 cos square u common out, so we get 2 cos u common out, we get 1 minus cos u. So again can be simplified this as 2 cos u by u square, and 1 minus cos u can be written as 2 sin square u by 2. So therefore we get the final result FC of u for the given problem is 4 cos u sin square u by 2 divided by u square. The next problem is find the Fourier sine transform of f of x is equal to e power minus ax divided by x where a greater than 0. So we want Fourier sine transform. So I'll write the formula of Fourier sine transform is given by integral 0 to infinity f of x sine ux dx. I'll substitute for the function now, where the function is e power minus ax by x. I'll write sine ux as it is. You can see here, so this type of integration cannot be done easily. So we cannot integrate directly. Therefore, applying Leibniz rule of differentiation under the integral sign. So that is, we have to differentiate both the sides with respect to u. Why with respect to u? So overall it is a function of u we have here, right? So if you differentiate both the side with respect to u, left side what we get, it is dfs of u by du. Right side d by du integral 0 to infinity e power minus ax by x sine ux dx. Now, so left side we keep this as it is. Right side, this ordinary derivative d by du under the integral sign become partial derivative. So how it will be? Integral 0 to infinity dou by dou u like this. Then e power minus ax by x sine ux. So if it is a partial derivative, you no need to apply any product rule like that, because where you have u present, in only one term u is present, that only we have to concentrate. Remaining all treated constants. So integral 0 to infinity, I keep e power minus ax by x is a treating constant here when you are differentiating with respect to u partially. And in differentiation of sine ux with respect to u will be cos ux into differentiation ux with respect to u will be give us x, then dx. Now see, this x gets cancelled, our integrand become simple. We have now integral 0 to infinity e power minus ax cos ux dx. Now you can easily integrate this like earlier problems. It gives us e power minus ax by a square plus u square and minus a cos ux plus u sin ux. So applying the limit 0 to infinity, Apply upper limit, it gives 0. Apply lower limit, minus 1 by a square plus u square, and in the bracket we get only minus a, because cos 0 is 1, sin 0 is 0. So it gives us a divided by a square plus u square. But this is what it is, not a Fourier cosine transform. It is a derivative of that. So we have df s of u by du. Now how to obtain the Fourier sine transform from this? So by integrating both the side, we get fs of u. So integration of a divided by a square plus u square du. So it is what this a keeping out, and integration of 1 over a square plus u square will be 1 by a tan inverse u by a, and plus constant. So this a gets cancelled. We have the result fs of u is tan inverse u by a plus c. Now to find the constant, you can write initially u values 0. Means fs of 0 is tan inverse 0 plus c. So it will be c. Tan inverse 0 is 0. Then what is fs of 0? By the starting result, like fs of u is what? Integral 0 to infinity e power minus ax by x sin ux dx. So here substituting u is 0, sin 0 will be 0. So therefore fs of 0 is 0, is tan inverse 0. So constant value is 0. Therefore our solution become, the Fourier sine transform of this problem will be tan inverse u by a. This is the result.